For the past few days, you've been hearing about the discovery of what appears to be the Higgs Boson particle. It's huge news in the science community. You're probably still trying to understand what this is all about and why, quite frankly, you should care about this. So we're at the University of Johannesburg here to speak to three professors who are going to help us understand what the Higgs Boson particle is and why it matters. It's difficult to grapple with issues around smashing protons at the speed of light, or perhaps looking at the Higgs field and how it switched on a trillionth of a second after the Big Bang. So to help us understand all of this, we're going to speak to the professors, and hopefully afterwards you'll get a full picture of why this matters so much. So come with me and let's go and hear what they have to say.
It was Peter Higgs, a British physicist, who put forward the concept of a particle, which he didn't name, of course, just to give the properties of mass to all the other particles that were known at the time. We take it for granted, we go to the wall, we flip a light switch and the lights come on. We know that electricity flows, etc. The physics behind that was first developed in the 1830s. It wasn't until about the 1880s, 1890s that the first power plants in the world were introduced, and that was seen as something of a luxury. We now take it for granted that whenever we go to a wall we can flip a switch and have electricity to power everything. It's so ingrained in our lives. We take it so much for granted, but it was between the discovery of the physics that goes into that and its first application, we've got 50 years. We may be seeing something similar 50 years from now. We don't know what it's going to be like. All we know, based on our past experience, that it will affect us fundamentally. Now, if we think of the analogy of the crowd in Sandton, you can imagine Sandton City and Nelson Mandela Square chock is full of a crowd. So we have all these little circles all making up the crowd. Each one of these would be a shopper or a tourist or what have you going through Sandton, and you'll see them coming by, and they're all moving in a way, all sorts of things. Each one of those would be the particle, but all the particles effectively make up the field. And what happens is you have a big celebrity. So there's my celebrity, big particle. Let's call it the W boson. That's another particle of nature that's thing. In our analogy, it's Millenna. All of these shoppers are going to immediately flock to them. And all of a sudden we're going to have a lot of crowd surrounding him. And the crowd is going to slow this one down. And that is the effect of mass. That is how mass comes up, in the fact of slowing this down. Now you might have another person coming through, Joe Bloggs. Let's call him the photon. No mass, particle of light. They're not going to even come close to this guy. They wouldn't care less. They're going to all flock to the big guy. This is our other shopper. Or another shopper, just not a shopper in the Higgs field. And he can go through and do anything he likes without any problems whatsoever. And so this is the difference between the two. The Higgs field is everything. The Higgs boson is just one of this crowd. And we're looking for this guy. That one particle in a crowd, in amongst. We can think of thousands of shoppers in Sandton. In terms of the particle in the Higgs field, we're talking of billions of billions. And we're trying to find one. That gives you an idea of how difficult this is.
I just want to illustrate to you that there is so much technology in even everyday items that we take for granted. Here's my cell phone. Would you be surprised to learn that inside this is quantum mechanics, general relativity, material science, even rocket science? This little device is communicating with several satellites right now. There's so much technology just here. Even take general relativity, the most abstract physics theory that you can imagine. General relativity is crucial to this phone. not crucial, it's not crucial to the phone. General relativity is crucial to GPS, which this phone is using. If this phone were not making general relativistic corrections, it would go out in terms of position by 12 kilometers a day. But now I want to show you that this phone is just made of everyday materials. I'm going to put my phone down on the ground and stamp on it. Okay, so as you can see, inside the phone is just sand and rock and oil. They make up all the material that is in this phone. And can you imagine that cavemen were walking all around the veld, not knowing that they were stepping on the telephones of future generations? It shows you that it's just human ingenuity and physics discoveries that are behind all of our technology. We can hardly imagine, but the new discoveries are going to lead to new technologies that for us are science fiction.
It will open doors to many different other questions, fundamental questions in physics to which we don't have answers yet. The question of dark matter, for example, could manifest in the, how the Higgs is produced and decay, for instance. So there are many other questions in physics. So this is just like a first step, but very, very important to tell us that yeah, we are on the right direction. If we didn't find the Higgs at all, then we have to scratch our head and say, where did we go wrong and how do we understand fundamental physics from that point? But finding the Higgs is really just the first step in many more experiments that will be done and many more theoretical approaches that will be proposed and that will be studies. Once we know that something like the Higgs is there, it just narrows the fields a little bit for us in how to go forward in our understanding of nature.
Eyewitness News, in touch, in tune, and independent.